All right, so here I want to fill in the gap in the lecture about the negative binomial distribution. Um, and like all of the other distributions, we're going to start with a story. And the story here is that it's a little bit like the exponential or the geometric distribution story. The story is we flip coins which aren't fair coins, probably, which land on heads with probability p. All right, that's our p here, probability p. Until we see R heads. All right, so let's make this buddy yellow, and this is our R here. So that's how our R and our P come into play. And then we say that in our version, the version that we're using in the class, although different sources sort of define these things slightly different, is that X is what? X is going to be the number of flips. Okay, so let's try and illustrate this. Let's actually first illustrate this instead of by using X. Let's make another variable Z, and let's say that Z is negative binomial, and we'll specify the R. The R is going to be 4, and we'll keep the P just P here. Okay, so what does this look like? Well, let's try and figure it out. So starting off here, the smallest thing that Z could be is 4. Why is 4 the smallest thing that Z could be? Well, if we want to get 4 heads, then we're going to need at least 4 flips to do it. Okay, and in order to do this in 4 flips, we are going to need to have that we get heads every time. 4 times in a row. These are all independent, and so this is going to be P times P times P times P, P to the 4th. All right. It's an important example, but things aren't too interesting yet. The next thing that I want to think about is what if we have k equals 5? Now I want to point out that there's a number of different things that could happen if we're going to flip until we see R heads. We could have heads, 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 tails, heads. Or we could have heads, heads, tails, heads, heads. Or we could have heads, tails, heads, heads, heads. Or we could have tails, heads, 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 heads. So there's sort of these 4 different outcomes, and any given one of these outcomes here is going to happen with probability. Since we've specified the order, these are going to happen with probability. There's 4 of them. 1 minus p to the power of 1 times p to the 4th. Okay, so that's great. One thing I want to point out is that we have almost all of the ways that we could have 4 heads and a tail, except for one, right? We do not have heads, 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 tails, because that would be handled in our 4 case, right? We got our 4th head after 4 flips. So what's going on here that I want to emphasize is that what we need to happen in order to have this happen in exactly k flips is that we have exactly 3 heads in our first k minus 1 flips, and then a head on the next one. Okay, so what I want to point out is that in general, what is this going to look like? It's going to look like, first we're going to have k minus 1 of these. All right, so here we were with k equals 5, so we have 4 of these. And we need all but the last one to, we're going to need r minus 1 heads. So here we have 3 heads in our first k minus 1, r minus 1 heads. And then what needs to happen? Well, how many flips are we going to have? We're going to have 1 minus p of them are going to be tails. So that's going to be k minus r. All right, and then the last one, and then not the last one, but the last part of this is that we're going to have exactly r heads. So that's where we get this p to the r. Okay. So this is actually in full generality, this is our PMF of x. Okay, remember x is the same thing as z, except for that instead of specifying r for x, instead of specifying 4 for our r, we just have a generic r. So that's why we get this generic r. All right, and we could check. We could say, all right, well, what if this is r is equal to 4 and k is equal to 5? Well, you can check. Well, what's going to be 4 choose 3? Well, it's going to be exactly this coefficient 4. All right. And then this has a coefficient of 1 here, and that's because we're looking at 5 minus 4. And this will have a coefficient of 4 here, because 4 is equal to r. Okay, so the negative binomial distribution is a really important distribution, but probably of the discrete distributions that we have, it comes up the least often. So what's important to do is to remember the story here, and then to think about how this goes. And we'll get some more practice with distributions like this in the future.